Welcome to the 820. This week we're going to talk about part 2 of the laser project. The transistors arrived. We're going to cover the circuit operation and the where we got the schematic. This is the original schematic, bill of materials, the final schematic, and then the operation of the circuit.
So here we have the full circuit working. The laser is reaching the detector. Maybe I've turned the my light off. And you can see the sort of illuminated. Let me put my finger down here. The light goes off. The light comes back on, off, and then must be something loose here. Maybe I need to redo the wires, and it's kind of dim. Let me work on it.
One of the things I wanted to show is debugging. These things just don't always work the first time you put it together. So I got some clips here of just me working through, proving to myself that it was working as it's supposed to.
We have a bug. So this is a first level circuit that I needed. We have electricity coming out of the battery, going into the laser diode circuit. It's also going across this rail into the photodetector, which is really acting as a switch. And then these two transistors are sort of daisy chained together. And so when they see this switch close, they essentially are another switch that turns the light on and off. And I will cover this schematic in more detail later. But this is effectively two pieces of the schematic from the patent that I was looking at in another episode.
On the patent, on the left is the light source with the laser. On the right at X is the detector. Eventually I want two detectors and a bunch of other stuff.
So then you want to know, well, did the light go out because the laser moved, or did the light go out because of some other reason? And it's probably some other reason. So we have a loose connection somewhere, and that's just the nature of breadboarding. So I'd like to get like some sort of a little PCB.
And I found these on Amazon. I've ordered them and they've arrived. So probably next week I may solder one up. I don't know.
And solder this up because I want to do more experiments with this circuit, getting more and more complicated as we move forward, as I learn more about how I've got some polarizing filters. So I will be putting a polarizing film in front of this LED to make it vertically polarized. And then I have a quarter wave plate, which will circularly polarize. And then I still should get light coming out the other end. But then I need to figure a way to build in a Pockle cell in the middle. And that I haven't figured out what I want to do. Either going to buy some lithium niobate crystal and put some metal plates on it, or I may find a optical modulator and see if that'll work. But I'm not familiar yet with the crystal structure and whether it needs to be cut on the... There's all kinds of information on X cut, Z cut, crystals, and I just absolutely know zero. I know less about what kind of crystal I need, but that'll be coming up. So anyway, I'm excited about this.
So on the schematic for the circuit, the left-hand side can be broken apart from the right. You could actually have two different circuits if you want. And so on the left, we have two AA batteries and the laser diode. And so if we just look at that, that could be a circuit all by itself. And that's the laser. For the detector circuit, I looked at this website, the Darlington pair design from AP Dylan, and I used that, but I modified the circuit. So if we go back to the original, my schematic, and look at the right-hand side, we can ignore the diode and just use the batteries for the same supply. His circuit used a 5-volt supply. I thought I'd just use the 3-volt batteries. And the way he reverse biased the diode, his circuit showed me a real quick way just to turn on an indicator. His circuit had two incandescent bulbs with a 15 ohm resistance, and that's, I believe, why I used the Darlington pair, which is why there's two transistors here. I switched that to use the LED and current limiting resistor, and I don't think we need both transistors, but I just wanted to hard code something really quickly. So this is a prism that I've ordered. It's due today, but I don't have it yet. This would be used in this analyzer section. It would split the light into X and Y polarization components so that I could replicate that part of the patent. Now, I'm just going to focus on polarization. This is an image I got from Adobe Stock. It sort of illustrates what's going on with the light. And this is another one more mathematical, but essentially polarization is a way of modifying, basically absorb the light you don't want and let the light you want pass through. For the bill of materials so far on this experiment, you could do what I've done for about $11.54 from DigiKey. This is a parts list for all the components on the schematic, including the battery case, even a breadboard. If you don't have a breadboard, it's all listed here. These are DigiKey part numbers from digikey.com. I spent a little bit more. I had bought this Adreno kit for $89. It's now $93, and I'm not sure yet to recommend it, but my plan is eventually you're going to want to control this circuit with the computer. So far, I've been really impressed with it. It's got a lot of fun little projects in it, so if you're interested in doing stuff, I would recommend it. It has a tutorial book. It looks really good. I also purchased this PSOC 5 development board. It does not come with a breadboard. It just comes with what's pictured here, and I was planning to work with that, but I haven't had time yet. So you may see me work with this in the future, but I wouldn't go rush out and buy one right yet. I've also purchased these optical transceivers. I've been looking for electrical optical crystals, and I haven't really found anything inexpensive. Everything Pockels sells from Edmund Scientific seems rather expensive, and since I don't what I'm doing, I figure, well, let me rip apart some really cheap transceivers. They might have optical crystals in them that I could play with and see if I can get voltage to affect the polarization of light. So once these come in, I'll probably do a video on disassembling them, and then I hope to do some videos on measuring the change in the amount of light based on voltage, which is how a modulator works in the first place. So I'm hoping I can kind of recreate this patent's behavior with very cheap components.